Hello, in this lecture we will find out the length of line segment X using two different methods. In the drawing we have quadrilateral ABCD. We know that side AD equals to 3 units, AB equals to 5 units, DC equals to 6 units, and this angle ADC equals to 90 degrees. And angle DCB equals to angle ABC equals to theta, and we want to find out the length of line segment BC that is actually equals to X. So we start with the first method. In the first method we will extend side AB and side CD until they intersect with each other. We will define the intersection point between extended line segment AB and extended line segment CD as E. So here we created triangle ABC. In triangle ABC we have two angles that are equal to each other. Those two angles that are both equal to theta, therefore they are equal to each other. So in the next step I will present to you a new rule, that is rule number 1. According to rule number 1, in front of equal angles in the triangle there are equal sides. So I write it down. So I will read rule number 1 again. According to rule number 1, in front of equal angles in the triangle there are equal sides. So we will focus on triangle EBC. We will focus on the big triangle, triangle EBC. In the big triangle, triangle EBC, angle EBC is equal to angle ECB and both angles are equal to theta. Therefore, according to rule number 1, side EB equals to side EC. EB equals to EC according to rule number 1. And repeat again. In triangle EBC, angle EBC equals to angle ECB, and they are both equal to theta. Therefore, according to rule number 1, side EB equals to side EC. Okay. So this will be question number 1. Side EB equals to 5 plus AE. And side EC equals to 6 plus ED. In conclusion, according to question number 1, 5 plus AE equals to 6 plus ED. We subtract 5 from this equation number 1, and we get that according to equation number 1, AE equals to 1 plus ED. Okay. We will define ED as A. ED equals to A according to our definition. Now we'll substitute ED by A in equation number 1. And we'll get it according to equation number 1. AE equals to 1 plus ED, and ED is A according to our definition. So in conclusion, we found out that according to equation number 1, AE equals to 1 plus A. Here we can write down that AE equals to 1 plus A. And actually, before we did the construction, we had quadrilateral ABCD. In quadrilateral ABCD, line segment CD is one side of quadrilateral ABCD. So line segment CD is one side of a quadrilateral. It must be a straight line. Okay, so CD is a straight line because it is one side of a quadrilateral. And then we extended the straight line CD by a straight line, and we got line segment CE. When you extend the straight line by a straight line, the result must be a straight line. Therefore, when we extended the straight line CD by a straight line, the result is CE. So CE must be a straight line. So we can write down that line segment CE is a straight line. So CE is a straight line. and we have also rule number 2. According to rule number 2, the sum of the angles on one side of a straight line is equal to 180 degrees. So I'll write it down. The sum of the angles on one side of a straight line is equal to 180 degrees. Alright, rule number 2 again. According to rule number 2, the sum of the angles on one side of a straight line is equal to 180 degrees. So, if you focus on this side of the straight line EC, if you focus on this side of the straight line EC, it's point D, then this is equals to 90 degrees according to what is given in the question. Then the sum of the angles here must be equal to the sum of the angles on this side of the straight line EC at point D must be equal to 180 degrees. Okay, so which angles we have at this side of the straight line EC at point D? We have here this angle that equals to 90 degrees plus angle ADE in total. The sum of those two angles must be equal to 180 degrees according to rule number 2. I'll repeat again. At one side of the straight line EC at point D, the sum of the angles must be equal to 180 degrees, that is to say 90 degrees plus the size of angle ADE in total must be equal to 180 degrees according to rule number 2. We will subtract 90 degrees from this equation and we get that the missing angle ADE is equal to 180 degrees minus 90 degrees, it is 90 degrees. So this angle ADE equals to 90 degrees. So if angle ADE equals to 90 degrees, it means that triangle ADE is a right triangle. So here the green triangle ADE is a right triangle. So we can implement the Pythagoras theorem on the green right triangle ADE. So on the right green triangle ADE, according to the Pythagoras theorem, Here PT is the abbreviation for Pythagoras theorem. According to the Pythagoras theorem, the square of the hypotenuse equals to the sum of the squares of the perpendiculars. That is to say, the square of the hypotenuse is AE squared. And it must be equal to the sum of the squares of the perpendiculars. That is to say, it must be equal to AD squared plus ED squared. I repeat again. According to the Pythagoras theorem, in the right great triangle ADE, AE squared equals to AD squared plus ED squared. So, according to the Pythagoras theorem, AE squared, AE is 1 plus A, so AE squared is 1 plus A squared equals to AD squared. AD is 3, so AD squared is 3 squared, that is 9, plus AD squared, plus ED squared. ED equals to A, so ED squared is A squared. So in conclusion, we found out that according to question number 2, one plus A squared equals to 9 plus A squared. We'll open the brackets on this side of equation number 2, and we'll get that according to equation number 2, one plus A squared equals to 1 squared, that is 1 plus A squared plus 2A, and it is equal to 9 plus A squared. Here we have A squared on both sides of equation number 2, so A squared will get cancelled, and we left only with 1 plus 2A, that is equal to 9. Here we will subtract 1 from this equation, equation number 2, and we get that according to equation number 2, A equals to 9 minus 1, that is 8. We'll divide this equation, equation number 2, by 2, and we'll get that according to equation number 2, A equals to 8 over 2, that is 4. So we found out that A equals to 4 units. So here we can write down that A equals to 4 units, and A plus 1 will be equal to 5 units. In the next step, we will define angle AED as alpha. In the great triangle AED, angle AED equals to alpha according to our definition. So in the great triangle AED, what is the value of cosine alpha? cosine alpha equals to ED over EA. Again, cosine alpha equals to ED over EA. So ED equals to 4 units and EA equals to 5 units. So in conclusion, we found out that cosine alpha equals to 4 over 5. Cosine alpha equals to 4 over 5. In the next step, I will present to you a new law, and we will implement the new law in this triangle, this big triangle, triangle ABC. The new law is the law of cosines. It is true in any triangle. So if we have triangle ABC, that could be any triangle. I'll repeat again, this triangle ABC could be any triangle, and the length of side AB is A units, the length of side AC is B units, and the length of side BC is C units, and the angle between side AB and side AC is alpha. Then, according to the law of cosines, we will get that C squared equals to A squared plus B squared minus 2 times A times B times cosine alpha. Okay? We can use this equation in any triangle. So we'll implement the law of cosines in this big triangle, triangle ABC. A equals to EB, A equals to EB, but EB is also equals to 5 plus 5, that is 10. So EB is also equals to 10. B equals to EC, EC equals to B, B equals to EC, and EC is also equals to 4 plus 6, that is also 10. C equals to BC, C equals to BC, it is also equals to X, and we have already found out that cosine alpha equals to 4 over 5, so I write it down. Cosine alpha equals to 4 over 5. So according to the law of cosines, we get that c squared, c equals to bc, so c squared is bc squared equals to a squared, a equals to eb, so a squared is eb squared. This will be equation number 3, plus b squared. B equals to ec, so b squared is ec squared minus 2 times eb times ec times cosine alpha. Okay, so according to equation number 3, bc squared equals to eb squared plus ec squared minus 2 times eb times ec times cosine alpha. So according to equation number 3, we get that bc squared, bc equals to x, so bc squared is x squared, and it is equal to eb squared. Eb equals to 10, so eb squared is 10 squared, that is 100, plus ec squared. Ec equals to 10, so ec squared is 10 squared, that is also 100, minus 2 times eb is 10, times ec is also 10, times cosine alpha. We already found out that cosine alpha equals to 4 over 5, so we substitute cosine alpha by 4 over 5. So, in conclusion, according to equation number 3, x squared equals to 100 plus 100 minus 2 times 10 times 10 times 4 over 5. So here, according to equation number 3, we will get that x squared equals to 100 plus 100 is 200, minus 10 times 10 is 100, 100 times minus 2 is minus 200, and we have to multiply it by 4 over 5. So according to equation number 3, we get that x squared equals to 200 minus, here we have minus 200 over 5 is minus 40, so here it is minus 40 times 4. In conclusion, according to equation number 3, we got that x squared equals to 200 minus 40 times 4 is minus 160. So according to equation number 3, x squared equals to 200 minus 160 is 40. So here we take a root out of this equation, equation number 3, and we get that x equals to the square root of 40, and 40 is 4 times 10, so we substitute 40 by 4 times 10, and the square root of 4 is 2. So in conclusion, we found out that x equals to either 2 times square root of 10 units, or in terms of numbers, it is equal to 6.32 units. Okay. The length of line segment x here it is equal either to 2 times square root of 10 units, or in terms of numbers, it is equal to 6.32 units. Okay, the length of this line segment BC, that is equal to x, is equal to either 2 times square root of 10 units, or in terms of numbers, it is equal to 6.32 units. So we finished with the first method. In the next step, I will present to you how to find out the length of line segment x according to the second method. In the second method, we'll do another construction from point A. From point A, we draw a straight line on DC in such a way that the straight line will be perpendicular to BC. Okay, so we define the touching point of the straight line from point A and DC is E. I repeat again that we draw the straight line AE in such a way that AE will be perpendicular to BC. So here we can write down that AE is parallel to BC. AE is parallel to BC. So actually AE is parallel to BC. AE is parallel to BC according to our construction. In the next step, from point E, we draw a straight line on BC in such a way that the straight line will be parallel to AB. We define the touching point of the straight line from point E and BC as F. I repeat again that EF is parallel to AB according to our construction. So, in conclusion, according to our construction, AB is parallel to BF, AE is parallel to BF, and EF is parallel to AB. Therefore, quadrilateral AEBF, this quadrilateral, is a parallelogram. So you can write down that quadrilateral AEBF is a parallelogram. Parallelogram. Okay, any quadrilateral that has two couples of sides that are parallel to each other is defined as a parallelogram. Here, the first couple of sides that are parallel in this quadrilateral to each other is AE is parallel to BF, and the second couple of sides that are parallel to each other is AB is parallel to EF. Therefore, this is exactly the definition of a parallelogram, that is to say, quadrilateral AEBF, this quadrilateral, is a parallelogram. Okay. In the next step, I will present to you a new rule that is actually rule number 3. According to rule number 3, corresponding angles between parallel lines are equal to each other. Corresponding angles between parallel lines are equal to each other. I repeat again, on rule number 3, according to rule number 3, corresponding angles between parallel lines are equal to each other. So, in our drawing, according to our construction, side AB is parallel to side EF. Side AB is parallel to side EF according to our construction. Therefore, because of the fact that side AB is parallel to side EF, those two angles are defined as corresponding angles, and they are located between the parallel lines AB and EF. Therefore, they will be equal to each other according to rule number 3. So that is to say, this angle, that is actually angle ABC, will be equal to this angle, that is actually angle EFC. And will be equal to each other according to rule number 3. I repeat repeat again. According to rule number 3, angle ABC must be equal to angle EFC. Okay, because those two angles are defined as corresponding angles that are located between the parallel lines AB and EF, therefore they are equal to each other according to rule number 3. Okay, but here angle ABC equals to theta according to what is given as the question. So we can write here that angle ABC, this angle equals to theta, and from this equation theta equals to angle ABC equals to angle EFC, we will derive that angle EFC is also equal to theta. Okay, this angle EFC equals to theta. Likewise, according to our construction, side AE equals to side BC. According to our construction, side AE equals to side BC. Therefore, those two angles that are defined as corresponding angles that are located between the parallel lines AE and BC will be equal to each other. That is to say, angle AED, this angle, will be equal to this angle that is actually angle DCB. AED will be equal to angle DCB. According to rule number 3, of course, but angle DCB equals to theta. According to what is given us in the question, angle DCB equals to theta. And from this equation, angle AED equals to angle DCB equals to theta, we will derive that angle AED is also equals to theta. This angle AED equals to theta also. It is given as the question that side AB equals to 5 units, side AD equals to 3 units, and side DC equals to 6 units. So here I will present to you a new rule that is actually rule number 4. According to rule number 4, the opposite sides of a parallelogram are equal to each other. The opposite sides of a parallelogram are equal to each other. So I read rule number 4 again. According to rule number 4, the opposite sides of a parallelogram are equal to each other. So we will focus on our parallelogram AEBF. In parallelogram AEBF, here the letter P is abbreviation for parallelogram. In parallelogram ABF, note that side AB equals to side EF, according to rule number 4, that the opposite sides of a parallelogram are equal to each other. But AB equals to 5 units according to what is given us in the question. AB equals to 5 units, and from this equation 5 equals to EB equals to EF, we will derive that EF is also equals to 5 units. EF equals to 5 units. So we can write here that EF equals to 5 units. In the next step, we'll focus on triangle EFC. In triangle EFC, angle EFC equals to angle ECF and they are both equal to theta. I'll repeat again. In triangle EFC, angle EFC equals to angle ECF and they are both equal to theta. Therefore, according to rule number 1, that states that in front of equal angles in the triangle there are equal sides, we conclude that EF equals to EC. Again, EF equals to EC because those two sides are located in front of those two equal angles. Therefore, EF equals to EC. Okay, but EF equals to 5 units. So can I tell that EF equals to 5 units? And from this equation 5 equals to EF equals to EC, we derive that EC is also equals to 5 units. EC equals to 5 units. So here EC equals to 5 units. And what is the value of line segment DE? The value of line segment DE, it is very easy to see from the drawing that DE equals to DC minus EC. I'll repeat again, the length of line segment DE equals to DC minus EC. So actually DE equals to DC, that is 6 units according to what is given in the question, minus EC, that is 5 units. 6 minus 5 is 1, so DE equals to 1. DE equals to 1 unit. Here DE equals to 1 unit. Now we'll focus on the right triangle ADE and we'll find out the length of the hypotenuse AE according to the Pythagoras theorem. So in this right triangle ADE, according to the Pythagoras theorem, the square of the hypotenuse equals to the sum of the squares of the perpendiculars. The square of the hypotenuse is AE squared it must be equal to the sum of the squares of the perpendiculars. That is to say, it must be equal to AD squared plus DE squared. I'll repeat again. In the right triangle ADE, according to the Pythagoras theorem, AE squared equals to AD squared plus DE squared. So AE squared equals to AD squared. AD equals to 3 units, so AD squared is 3 squared, that is 9, plus DE squared. DE equals to 1, so DE squared is 1 squared, that is 1. So, in conclusion, we found out that according to equation number 1, AE squared equals to 9 plus 1, that is 10. I'll repeat again, according to equation number 1, AE squared equals to 10. Here we take out of this equation number 1, and we get that according to equation number 1, AE equals to the square root of 10 units. AE equals to the square root of 10 units. Here AE equals to the square root of 10 units. Now we'll use rule number 4 in order to find out the length of side BF. We'll focus on parallelogram AEBF, this parallelogram. In this parallelogram, according to rule number 4, AE equals to BF. AE equals to BF according to rule number 4. I'll repeat again. According to rule number 4, that the opposite sides of a parallelogram are equal to each other, we get that AE in parallelogram ABF, AE equals to BF. But A equals to the square root of 10 units, so we can write here that A equals to the square root of 10 units. And from this equation, square root of 10 units equals to A equals to BF. We will derive that BF is also equals to the square root of 10 units. BF equals to the square root of 10 units. So what is the length of side FC? The length of side FC, from the drawing it is very easy to see that FC equals to BC minus BF. I'll repeat again. FC equals to BC minus BF. So actually FC equals to BC, that is X, according to what is given in the question, minus BF, that is square root of 10 units. So in conclusion, we found out that FC equals to X minus square root of 10 units. So we can write here that FC, side FC, equals to X minus square root of 10 units. In the next step, we will focus on triangle EFC. This triangle EFC. Actually, triangle EFC is an isosceles triangle because of the fact that side EF equals to side EC. EF equals to EC equals to 5 units. I will repeat again that triangle EFC is an isosceles triangle. EFC is an isosceles triangle because of the fact that side EF equals to side EC. And the base of the isosceles triangle EFC is FC. Okay, so FC is the base, of the isosceles triangle EFC. I'll repeat again. Side FC is the base of the isosceles triangle EFC. In the next step, we will do a construction. From point E, we will draw perpendicular on FC. So actually this angle, this angle equals to 90 degrees, and this angle also equals to 90 degrees according to our construction. We define the touching point of the perpendicular from point E and FC as M. So we know that line segment EM is perpendicular to FC. For that reason, line segment EM is the height to the base FC. So write it down. EM is the height to the base FC. Okay, so right here that line segment EM is the height to the base FC. I'll repeat again that EM is the height to the base FC, because any line segment that exists from a vertex of a triangle and it is perpendicular to another side of the triangle, it is defined as the height to that side. So here, this line segment EM exists from point E and it is perpendicular to side FC, therefore EM is the height to side FC that is actually the base. That is to say, EM is the height to the base FC. So repeat again that EM, side EM is the height to the base FC. Then we also have rule number 5. According to rule number 5, the height to the base in an isosceles triangle bisects the base. The height to the base in an isosceles triangle bisects the base. So I read rule number 5 again. According to rule number 5, the height to the base in an isosceles triangle bisects the base. So we focus on the isosceles triangle EFC. On the isosceles triangle EFC, according to rule number 5, the height EM to the base FC bisects the base FC. So, first of all, according to rule number 5, the height EM divides the base FC into two equal parts, that is to say, FM equals to MC. So in triangle EFC, the isosceles triangle EFC, Fn equals to MC according to rule number 5. FM equals to MC. So according to rule number 5, the height EM bisects the base FC. It means that it divides it into two equal parts. So if the first part is equal to FC over 2, then the second part must be also equal to FC over 2 because of the fact that the height divides the base FC into two halves. If it divides it in two halves, it means that each half must be, that each part must be equal to one half. So side AM will be equal to FC over 2, and side MC will be also equal to FC over 2. So here FC over 2, FM equals to FC over 2 and MC equals to FC over 2. Why? Because the height EM bisects the base FC. It means that it divides it into two halves, and each half equals to FC over 2. So according to rule number 5, MC equals to FC over 2. But we have already found out that FC equals to x minus square root of 10 units. So FC equals to x minus square root of 10 units, and if we divide it by 2, we get the value of MC. So in conclusion, MC equals to x minus square root of 10 over 2. So we can write here that MC equals to x minus square root of 10 over 2. In the next step, we will prove that this right green triangle is similar to the small green triangle, triangle ADE. But first of all, in this green right triangle, triangle EMC, this angle equals to 90 degrees, this angle equals to theta, so this angle must be equal to 90 degrees minus theta in order to complete the sum of the angles in this right green triangle to 180 degrees. This angle must be equal to 90 degrees minus theta. Why? Because 90 degrees minus theta plus theta is 90 degrees, and 90 degrees plus 90 degrees is 180 degrees. For that reason, this angle must be equal to 90 degrees minus theta. For exactly for the same reason, this angle must be also equal to 90 degrees minus theta. Again, this angle equals to 90 degrees, this angle equals to theta, so this angle must be equal to 90 degrees minus theta. So those two angles, they are both equal to 90 degrees minus theta, therefore they are equal to each other. So here, angle EAD, this angle equals to this angle, this is actually angle MEC, and they are both equal to 90 degrees minus theta, therefore they are equal to each other. So I repeat again. We'll prove that triangle ADE is similar to triangle EMC. Why they are similar to each other? First of all, angle AED equals to angle MEC, and both angles are equal to 90 degrees cos theta, therefore they are equal to each other. In addition, those two angles are both equal to theta, therefore they are equal to each other. So angle AED is equal to this angle that is actually angle ECM, and both angles are equal to theta. I'll repeat again. Angle AED equals to angle ECM, they are both equal to theta, therefore they are equal to each other. And finally, we have those two angles that are both equal to 90 degrees, therefore they are equal to each other. So this angle that is actually angle ADE is equal to this angle that is actually angle EMC, and both angles are equal to 90 degrees. I'll repeat again. Angle ADE equals to angle EMC, and both angles are equal to 90 degrees, therefore they are equal to each other. Therefore, all the angles of triangle ADE can go into all the angles of triangle EMC, therefore those two triangles are similar to each other according to angle similarity rule. Okay, so I write it down. Triangle ADE is similar, this is the sign of similar, to triangle EMC, according to angle similarity rule. And from the fact that the two green triangles are similar to each other, we'll conclude hence AE over EC equals to DE over MC. I will repeat again, from the fact that the two right triangles are similar to each other, we will conclude that AE over EC equals to DE over MC. AE equals to the square root of 10 units. EC equals to 5 units. DE equals to 1 unit, and MC equals to x minus square root of 10 over 2. So in conclusion, according to equation number 2, we found out that square root of 10 over 5 equals to 1 over x minus square root of 10 over 2. Here we will move 2 to the numerator and x minus square root of 10 to the denominator, and we will get that according to equation number 2, square root of 10 over 5 equals to 2 over x minus square root of 10. Here we will cross multiply this equation number 2, and we will get that according to equation number 2, square root of 10 times x minus square root of 10 equals to 5 times 2, that is 10. 10 is square root of 10 times square root of 10, so we substitute 10 by square root of 10 times square root of 10, and we get that according to equation number 2, square root of 10 times x minus square root of 10 equals to 10 is square root of 10 times square root of 10. Here we'll divide this equation number 2 by square root of 10, and we'll get that according to equation number 2, square root of 10 over square root of 10 is 1, so here we left only with x minus square root of 10, and we have here square root of 10 times square root of 10 over square root of 10 is square root of 10. So here we will add square root of 10 to this equation number 2, and we will get that according to equation number 2, x equals to square root of 10 plus square root of 10 is 2 times square root of 10. So x, the variable that we are looking for, the line segments that we are looking for, equals to either 2 times square root of 10 units, or in terms of numbers it is equal to 6.32 units. Okay. Here I'll repeat again that this line segment x, that is actually equals to side BC, it is equals to either 2 times square root of 10 units, or in terms of numbers it is equals to 6.32 units. Okay, we finished with the second method. In the next step I will summarize the lecture. We will start with the first method. I repeat on the question of the lecture. Here we have quadrilateral ABCD. We know that side AB equals to 5 units, AD equals to 3 units, DC equals to 6 units, angle ADC equals to 60 degrees, angle ABC equals to angle DCB equals to theta, and we want to find out the length of side BC that is actually equals to x, according to what is given as the question. So the first thing that we did here is we did here construction. We extended side BA and side CD by a straight line until they intersect with each other at point E. So we created here triangle ABC. Triangle ABC, we have two angles that are equal to each other. Those two angles that are equal to each other, they are both equal to theta, therefore they are equal to each other. Then I presented to you rule number 1. According to rule number 1, in front of equal angles in the triangle, there are equal sides. So we will relate to triangle EBC. In this triangle EBC, we have two angles that are equal to each other, they are both equal to theta. So angle in triangle EBC equals to angle CEB, angle ABC equals to angle ECB, angle ABC equals to angle ECB, and they are both equal to theta, therefore they are equal to each other. Therefore, according to rule number 1, in front of those two equal angles there are equal sides. That is to say, in front of those two equal angles we have side AB and side EC. And therefore they are equal to each other according to rule number 1. That is to say, EB equals to EC according to rule number 1. Here AB equals to 5 plus AE. EB equals to 5 plus AE, and EC equals to 6 plus ED. EC equals to 6 plus ED. So according to equation number 1, 5 plus AE equals to 6 plus ED. We subtracted 5 from this equation number 1, and found out that AE equals to 1 plus ED. Then we defined ED as A. Here ED equals to A according to our definition. So we can substitute ED by A in equation number 1. So we did it, and we got that A equals to 1 plus ED, but ED equals to A. So we substitute ED by A, and we got that A equals to 1 plus A according to equation number 1. So we can write here that A equals to 1 plus A. So here, before we did the construction, we had quadrilateral ABCD. So here, CD is one side of a quadrilateral ABCD, therefore it is absolutely a straight line. CD is a side of a quadrilateral, must be a straight line. Then we extended the straight line CD by a straight line, therefore the result must be also a straight line. The result that is CE must be a straight line also, because when you extend a straight line by a straight line, the result must be a straight line, therefore the result that is CE must be a straight line. That is to say, CE is a straight line. Then we have rule number 2. According to rule number 2, the sum of the angles on one side of a straight line is equal to 180 degrees. So here, if we focus on this side of the straight line CE at point D, then the sum of the angles here must be equal to 180 degrees. So which angles we have at this side of EC at point D? We have here 90 degrees, and again ADE. In total, the sum of those two angles must be equal to 180 degrees according to rule number 2. So here at point D, 90 degrees plus angle ADE must be equal to 180 degrees according to rule number 2. We subtracted 90 degrees from this equation and found out that the missing angle ADE equals to 90 degrees. So this angle equals to 90 degrees. So if angle ADE equals to 90 degrees, it means that the green triangle is a right triangle. Okay, so we can implement the Pythagoras theorem on the green right triangle ADE according to the PT is abbreviation for Pythagoras theorem. According to the Pythagoras theorem, the square of the hypotenuse equals to the sum of the squares of the perpendiculars. That is to say, the square of the hypotenuse is AE square, and it must be equal to the sum of the squares of the perpendiculars. That is to say, it is equal to AD square plus ED square. So AE square, AE is 1 plus A, so A square is 1 plus A square, and it is equal to AD square. AD is 3, so AD square is 3 square, that is 9. Plus ED square. ED equals to A, so ED square is A square. So in conclusion, found out that according to equation number 2, 1 plus A square equals to 9 plus A square. Here we open the brackets on this side of equation number 2, and we got that 1 plus A square equals to 1 plus A square plus 2A, and it is equal to 9 plus A square. Here we have A square on both sides of equation number 2, so A square will get cancelled, and we left only with 1 plus 2A, that is equal to 9. Here we subtracted 1 from this equation, equation number 2, and we found out that according to equation number 2, 2A equals to 8. We divided equation number 2 by 2, and we found out that A equals to 8 over 2, that is 4. So A equals to 4, we can write here that A equals to 4, therefore A plus 1 will be equal to 5. Then we focused on the green triangle, triangle AD. We defined angle AD as alpha. So in this green right triangle, triangle AD, we know that cosine alpha equals to ED over EA. In the green right triangle AD, cosine alpha equals to ED over EA. ED equals to 4, EA equals to 5, so in conclusion we found out that cosine alpha equals to 4 over 5. Here cosine alpha equals to 4 over 5. Then I presented to you the law of cosines, and we implemented the law of cosines in triangle ABC, the big triangle ABC. So what is the law of cosines? The law of cosines is true in any triangle. In triangle ABC, here triangle ABC could be any triangle. We know that the length of side AB is A units, the length of side AC is B units, and the length of side BC is C units, and the angle between side AB and side AC is alpha. Then according to the law of cosines, C squared equals to A squared plus B squared minus 2 times A times B times cosine alpha. This equation is true in any triangle. Okay, you can use this equation in any triangle. Therefore, we used this equation, the law of cosines, in our triangle EBC, the big triangle ABC. If A equals to EB, but EB also equals to 5 plus 5, that is 10. B equals to EC, but EC is also equals to 4 plus 6, that is also 10. And C equals to BC. BC equals to C, and C is also equals to X. And this is angle alpha. And we already found out that cosine alpha equals to 4 over 5. Okay? So according to the law of cosines, C squared is BC squared. Here, BC squared equals to EB squared plus EC squared minus 2 times EB times EC times cosine alpha. Okay? BC is X, so BC squared is X squared. EB is 10, so EB squared is 10 squared, that is 100. EC is 10, so EC squared is also 10 squared, that is 100. Minus 2 times EB is 10 and EC is 10, so it is minus 2 times 10 times 10, and cosine alpha is 4 over 5, so we substituted cosine alpha by 4 over 5, and in the conclusion we found out that according to equation number 3, x squared equals to 100 plus 100 minus 2 times 10 times 10 times 4 over 5. So x squared equals to 100 plus 100 is 200, and here we have minus 2, 10 times 10 is 100. 100 times minus 2 is minus 200 times 4 over 5. So according to this equation number 3, we found out that x squared equals to 200, and here minus 200 over 5 is minus 40. So this expression equals to minus 40 times 4. So in conclusion, we found out that x squared equals to 200 minus 40 times 4 is minus 160. Minus 160. So in conclusion, x squared equals to 200 minus 160. 200 minus 160 is 40. So in conclusion, we found out that x squared equals to 40. We took a root out of this equation, equation number 3, and we found out that x equals to the square root of 40. 40 is 4 times 10, so we substituted 40 by 4 times 10, and found out that x equals to the square root of 4 is 2. So in conclusion, x, the line segment that we are looking for, equals to either 2 times square root of 10 units, or in terms of numbers, it is equals to 6.32 units. Okay? This line segment x equals to either 2 times square root of 10 units, or in terms of numbers, it is equal to 6.32 units. We finished with the first method. Then I presented to you how to find out the length of line segment x that is equal to BC according to the second method. In the second method we did another construction. Here from point A we draw a straight line on DC in such a way that AE is parallel to BC. So in the first step, we did the construction in such a way that AE is parallel to BC. Then we did another construction. From point E, we drew a straight line on BC in such a way that EF is parallel to AB. Again, EF is parallel to AB according to our construction, and A is also parallel to BC, also according to our construction. So we created here quadrilateral AEBC, AEBF. This quadrilateral is a parallelogram. Why? Because it has two couples of sides that are parallel to each other. This is exactly the definition of a parallelogram. Here AE is parallel to BF and AB is parallel to EF. For that reason, quadrilateral AEBF is a parallelogram. Then I presented to you rule number 3. According to rule number 3, corresponding angles between parallel lines are equal to each other. According to our construction, AB is parallel to EF. AB is parallel to EF. Therefore, those two angles that are defined as corresponding angles and they are located between the parallel lines AB and EF will be equal to each other. So that is to say, angle ABC equals to angle EFC according to rule number 2. According to rule number 3, of course, angle ABC equals to angle EFC according to rule number 3. But according to what is given as the equation, angle ABC equals to theta. So we can write here that angle ABC equals to theta, and from this equation theta equals to angle ABC equals to angle EFC, we will derive that angle EFC also equals to theta. This angle EFC, is also equals to theta. Okay, likewise, according to our construction, AE is parallel to BC. Therefore, those two angles that are defined as corresponding angles and are located between the parallel lines AE and BC, they will be equal to each other. That is to say, this angle that is actually angle AD equals to this angle that is angle DCB. Because of the fact that AE is parallel to BC, here AE is parallel to BC according to our construction, then angle AED will be equal to angle ABC according to rule number 3, of course. According to rule number 3, but it is given as the question that this angle DCB equals to theta. So we can write here that angle DCB equals to theta, and from this equation angle AED equals to angle BCD equals to theta, we will derive that angle AED, this angle, is also equal to theta. Okay, then I presented to you rule number 4. According to rule number 4, the opposite sides of a parallelogram are equal to each other. So we will relate to our parallelogram ABF. In this parallelogram, the opposite sides are equal to each other. That is to say, AB is equal to EF. Again, according to rule number 4, AB equals to EF in parallelogram ABF. But AB equals to 5 units according to what is given as the equation. So we can write here that AB equals to 5 units, and from this equation 5 equals to AB equals to EF, we will derive that EF is also equals to 5 units. Okay, here EF is also equals to 5 units. So in triangle EFC, we have two angles that are equal to each other. Those two angles are both equal to theta, therefore they are equal to each other. That is to say, in triangle EFC, we have angle EFC that is equal to angle CF, and they are both equal to theta, therefore they are equal to each other. Therefore, according to rule number 1, in front of those two equal angles, they are equal sides. That is to say, EF is equal to EC according to rule number 1. EF is equal to EC according to rule number 1, but we have already found out that EF equals to 5 units. So we can write here that EF equals to 5 units, and from this equation 5 equals to EF equals to EC, we derive that EC is also equal to 5 units. Here EC is also equal to 5 units. So what is the length of time segment DE? For the drawing it is very easy to see that DE equals to DC minus EC. Okay, so here DE equals to DC minus EC, so DE equals to DC, that is 6 units, minus EC, that is 5 units, so DE equals to 6 minus 5, that is 1 unit. So here DE equals to 1 unit. Then we implemented the Pythagoras theorem on the green small right triangle, triangle AD. The square of the hypotenuse equals to the sum of the squares of the perpendiculars. The square of the hypotenuse is AE squared, and it must be equal to AD squared plus EC squared. So AE squared equals to AD squared. AD equals to 3, so AD squared is 3 squared, that is 9, plus DE squared. DE is 1, so DE squared is 1 squared, that is 1. So in conclusion, we found out that AE squared according to equation number 1 equals to 9 plus 1, that is 10. We took out of this equation number 1, and found out that AE equals to the square root of 10 units. Here AE equals to the square root of 10 units. Then in a parallelogram AEBF, the opposite sides of a parallelogram are equal to each other, that is to say AE equals to BF. Here AE equals to BF according to rule number 4, that the opposite sides of a parallelogram are equal to each other, but we have already found out that A equals to square root of 10 units, so from this equation square root of 10 units equals to AE equals to BF, we derive that BF is also equal to square root of 10 units. Here BF is also equals to square root of 10 units. And what is the length of CF? CF equals to BC minus BL. Here FC equals to BC minus BF, BC equals to X, according to what is given as the equation. We just now found out that BF equals to square root of 10, so in conclusion found out that FC equals to X minus square root of 10 units. Here FC equals to X minus square root of 10 units. Okay? Then we focused on triangle EFC. This triangle EFC, is an isosceles triangle because of the fact that side EA equals to side EC equals to 5 units. So here, triangle EFC is an isosceles triangle because of the fact that side EF equals to side EC, and FC is the base of the isosceles triangle, triangle EFC. FC is the base of the isosceles triangle, triangle EFC. And then from point E we draw perpendicular on FC. So this angle equals to 90 degrees and this angle equals to 90 degrees according to our construction. So EA is perpendicular to FC, it means that EM is perpendicular to FC, it means that EM is the height to the base FC. Okay, here EM is the height to the base FC. And we have rule number 5 that the height to the base in an isosceles triangle bisects the base. So the height EM to the base FC of the isosceles triangle EFC bisects the base FC. It means, what is the meaning of the sentence that the height EM bisects the base FC? It means that it divides the base FC into 2 equal parts. That is to say, Fm equals to MC according to rule number 5. Fm equals to MC according to rule number 5. And because of the fact that it bisects the base FC, it means that it divides it into 2 equal parts, that each part equals to 1/2. So if this part of FC equals to Fc over 2, this part will be also equal to Fc over 2. So in conclusion, we found out that according to equation, rule number 5, Fc over 2 equals to Fm equals to Mc. So that is to say, Mc equals to Fc over 2. So Mc equals to Fc over 2. Fc is x minus square root of 10, and if we divide it by 2, we will get Fmc. So in conclusion, Mc equals to x minus square root of 10 over 2. Here, Mc equals to x minus square root of 10 over 2. Then we proved that those two right triangles are similar to each other. So first of all, in this right triangle, this angle equals to 90 degrees, this angle equals to theta, so this angle must be equal to 90 degrees minus theta in order to complete the sum of the angles in this right triangle to 180 degrees. This angle must be equal to 90 degrees minus theta. For the same reason, this angle must be also equal to 90 degrees minus theta. Okay? So here, first of all, angle in these two right triangles, why they are similar to each other? First of all, angle EAD equals to angle MEC, and both those two angles are equal to 90 degrees minus theta. Here, both those two angles are equal to 90 degrees minus theta, therefore they are equal to each other. In addition, both those two angles are equal to theta, therefore they are equal to each other. So angle AD equals to angle ECM equals to theta. And finally, those two angles are both equal to 90 degrees, therefore they are equal to each other. Angle AD equals to angle EMC equals to 90 degrees. Therefore, we proved the right small triangle ADE is similar to the right big triangle EMC according to angle similarity rule. And from the fact that those two right great triangles are similar to each other, we will conclude that AE over EC equals to DE over MC. I'll repeat again. AE over EC equals to DE over MC. So AE equals to square root of 10 units, EC equals to 5, D equals to 1, and MC equals to x minus square root of 10 over 2. We moved 2 to the numerator and x minus square root of 10 to the denominator, and found out that according to equation number 2, square root of 10 over 5 equals to 10 over x minus square root of 10. We cross multiply this equation number 2, and we got that according to equation number 2, square root of 10 times x minus square root of 10 equals to 10. Because 5 times 2 is 10. Then we substitute 10 by square root of 10 by square root of 10, and we got that according to equation number 2, square root of 10 times x minus square root of 10 equals to square root of 10 times square root of 10. We divided this equation number 2 by square root of 10, and we got that according to equation number 2, here square root of 10 over square root of 10 is 1, so we left in this side of equation number 2 only with x minus square root of 10, and in this side of equation number 2, square root of 10 over square root of 10 is square root of 10, so we left only with square root of 10. We added square root of 10 to this equation number 2, and we got that x equals to square root of 10 plus square root of 10 is 2 times square root of 10. So the answer to the question is that x equals to either 2 times square root of 10 units, or in terms of numbers, it is equal to 6.32 units. Here, x, line segment BC that is equal to x, it is equal to either 2 times square root of 10 units, or in terms of numbers, it is equal to 6.32 units. So in both methods, we arrive to the same answer for x. Okay, thank you very much.